Hi all, welcome back. And in this video, we are going to learn about Poset. So earlier we have seen what is called POR, partially ordered relation, and we know that POR, a relation is said to be POR if it is reflexive, if it is antisymmetric, okay, and it has to be transitive as well. So any relation on set A is said to be a partially ordered relation if it is reflexive, antisymmetric, and transitive. For example, we defined that less than equal to on Z is a POR. Similarly, we defined that division on Z plus, because 0 0 is not included, so this operation on Z plus is a POR. Similarly, we define that a subset operation on the power set of S is also a POR. So all these kind of are kind of POR. Yeah, otherwise, it is known as partially ordered relation. Now we are going to see what a poset is. So poset is very much similar to partially ordered relation. So poset is defined as a set P, a set P together with the POR, a set P together with POR, that is the partially ordered relation, that is represented as P and R. So P is our set and R is a partially ordered relation on set P. Sorry. So this is a poset. Okay. So this is a partially ordered set. Partially ordered set. Okay, so this is a poset. A set P all together with a POR is said to be a partially ordered set. So if we say that Z and then we have less than equal to, then it is also a poset. Why? Because Z is the set and this operation on Z is a POR. So if any operation or defined on the set is a POR, then altogether both are known as poset. Okay, so this is a poset. Now, if we see about the some results on poset, so the results are like, okay, so number one, if R is a relation and R inverse is its inverse, and if R is a relation defined onto the poset, then it or R is a poset, then if R is a reflexive, then R inverse is also reflexive. In R inverse, we are just reversing the ordered pair, right? So R is reflexive, then R inverse is also reflexive. If R is antisymmetric, okay, that is if 1 2 present, then 2 1 should not be present. Then if 2 1 is present, 1 2 should not be present, right? So our inverse is also antisymmetric, right? If we say that R is a transitive, then R inverse is also transitive. Okay. So this is also one condition that is satisfied by both. And if all together these conditions are satisfied, then we can say that R is a POR. So R inverse is also a POR. Okay. Now, the second result is that if PR is a poset, if PR is a poset, then PR inverse is also a poset. Okay, PR inverse is also a poset, and hence we can say that PR and PR inverse are duals. PR inverse are duals. Okay, so this is a new term, duals. So if R is a poset, R inverse is a poset. So PR and PR inverse are duals, right? So we can give some example of duals. So duals is nothing but the inverse operation. I mean, if one is a poset, then the inverse of that is also a poset, right? So let's see some of the duals that is associated with that. So here are some example of duals. So this is PR and this is PR inverse. are inverse, right? So if we consider both of these, then in the very first, if we have z and less than equal to, so its inverse is z greater than equal to, right? So both these are poset. Similarly, if we have a is a subset of z, then z is what? All the integer. Then a and less than equal to is a poset. So similarly, if a is a subset of z, and we can say that a and greater than equal to is poset. Similarly, if we have z plus set of all positive integers and operation is division, so if this is a poset, then we can say that z plus and multiple of, okay, is also a poset. So this is the inverse, multiple of is the inverse of division, right? Then we have something called if a is a subset of z plus. Okay, so a is a subset of z plus, so we can say that a and division is a poset. Similarly, if a is a subset of z plus, we can say a and multiple of is a poset, right? Now let's see another one, that is fifth. So if dn and division is a poset, okay, then we can say that dn and multiplication of is also a poset, right? Similarly, we have power set. So if power set of s and this operation is a subset operation, this is a poset, then we can say that power set and just reverse operation is also a poset. Okay, so right, these are the duals and they are the poset. Now let's see what does dn means. So we can say that dn is a dn set of all positive divisors of n. Okay, so dn is the set of all positive divisors of n. So d8 we can write as 1 2 4 8, something like that. So n denotes the number. Okay, so poset denotion is like this. Okay, so this we need to remember. Next we are going to learn about definition and of poset and toset, so how they are associated. So this we are going to see next. That's all from this part. So if you do have any comments or questions, please do comment in the comment section, and thank you very much for watching.